the decision tree approaches. Okay. So that was discussed in the last lecture. Today we'll see that how probability based inferencing or decision making is actually done. Okay. Uh, so these are the topics that we'll be covering in this particular module, and this would stretch to the next lecture as well. So we'll talk about random variables. This might be a sort of revision for some of you. We'll talk about joint and marginal distributions, conditional distributions, product rule or chain rules or Bayes rule, inferencing, and then independence. And today we'll most probably cover up till conditional distribution, and if we have time, we might move to the other topics as well. Okay, so here is an example of ghost buster, and this example is such that you have a, let's say you have a grid, and within that grid you have ghost present in some of this, in one of these cells, right? And the purpose is that you have to find out the ghost from here, from this particular cell. The game goes like this, that if you click on any cell here, then a box of different colors appear. And these different colors are red, orange, yellow, and green. And these colors are dependent upon that the cell that you have selected, how far that cell is from the ghost. The idea here is, or the winning situation would be that you'll have to hit a cell where the ghost is present. Okay. So if you click on a cell, then and if red color appears, that means you have clicked on a cell जहाँ पे ghost है, right? If the color red appears, the probability that the red color indicates that you are very, very close to the ghost, or you are you are present in a cell that contains the ghost. That probability is around 0.05. So that means that that probability is very low, that you are at a distance of from the ghost if the color that if the color appears to be red. Okay, so it's very, very low. If orange appears, you say that the probability of orange, given that the distance from the ghost is 3 cells, the probability is 0.15, and you can see that yellow की probability 0.5 है और green की probability 0.3. So if a yellow cell appears, that means that it's primarily furthest from, the chances are that it's relatively far away from the ghost. That's how this um, this appears, this grid appears. Okay. So if you are on the ghost, then the red color appears. If you are 1 or 2 cells away, then orange color appears. If you are 3 or 4 cells away, then the yellow appears. And if you are 5 plus away, then the green cell appears, or the green cell appears. ठीक है जी? So you win the game if you hit upon the ghost, right? So I have a small video here that explains that how this works, and I'll just show you that how this video, how does this work. Okay, so here is the video. So here is a grid, and then you can click on any of the cells and a color will appear. Okay, so you will just see in a while that if you click on a cell, then some color will appear, and that color will indicate the distance from the ghost. Okay, okay, yeah. So here, so you can see that um, if you click on this cell, you got a color that appears, and this color would primarily indicate that how far you are from the ghost itself, right? uh, and there might be a possibility कि जिस सेंसर से आप ये कलर डिटेक्शन कर रहे हैं या डिस्टेंस फ्रॉम द गोस्ट डिटेक्ट कर रहे हैं that sensor might malfunction. ठीक है, so there might be a possibility कि ये error हो. So here you can see कि आपने इस cell को clear किया and the red has actually appeared. So it might be an error. ठीक है, ये possibility है कि ये हो सकता है ये error हो. How can you confirm कि ये error नहीं है? You can actually confirm that by clicking on the neighboring cells. ठीक है. So if you click on the neighboring cells, then you will see that okay. So mostly it's yellow. ठीक है. Mostly the color that appears is yellow. And if you remember from our discussion, yellow means, oh, okay, green or yellow, that would mean that it's actually away, quite far away from, or it's not very close uh, to the ghost. ठीक है. If orange color appears, then it might be representing again some distance. If green appears, then again it represents that it's far away, and that would basically indicate you the color that appears around this particular grid. That would indicate, so these colors would indicate that the whether this red is giving you some sort of correct information or not. Okay, so let me just restart this. Okay, so here it goes. So you can then start clicking on the neighboring cells and then find out कि क्या neighboring cells क्या बता रहे हैं. अगर तो ये false reading थी, ये red वाली, तो neighboring cells ज़्यादा distance बताएंगे, otherwise कम distance बताएंगे. ठीक है. And this way you can continue, and then if two red appears, then it's your judgment call कि आपने किस के ऊपर क्लिक करके ये आइडेंटिफाई करना है कि यहाँ पे गोस्ट होगी. सो यू हैव गॉट अनदर रेड हेयर, सो यू कैन सी दैट देयर आर टू रेड्स हेयर. ठीक है. एंड नाउ आप या इसको बस्ट कर दें या इसको बस्ट कर दें. सो यू क्लिक ऑन एनी ऑफ दीज टू सेल्स एंड यू से दैट ओके इन माय व्यू गोस्ट इधर है, या यू कैन से गोस्ट इधर है. सो इन योर ओपिनियन बेस्ड अपॉन दिस कलर्स, आपके ख्याल में गोस्ट किधर हो सकती है? यहाँ पे है या यहाँ पे है? जी. राइट. सो व्हाट डू यू थिंक? The right box. Okay, the right box. So let's just see. Okay, if you if you click on that and then you say burst, तो then let's see कि क्या ghost उधर उधर होगी या ghost उधर नहीं होगी. ठीक. Right. So the probably the cell that contains more orange color around it, that would, so here you can see that okay, your guess was right. Right. So you got a hit here. So that means that ghost was really present here. So there is only one ghost, let's say. तो उस केस में it would mean कि ये जो वैल्यू आपके पास लेफ्ट साइड पे जो रेड कलर आया, that was an error, that was a sensor reading, that was a faulty sensor reading. ठीक है. Okay. Now, here we are not using any probability. Like this is an inferencing process, a decision-making process where you don't have any sort of measure which would indicate that what is the probability कि ghost इस cell में present है या इस cell में present. Based upon the colors that you have got in the neighboring cells, you can actually give some probability value here. You can say that okay, with this much probability, we can identify that the ghost might be present here or the ghost might be present here. If we assign some numbers, let's say we can say that the probability that the ghost will be present here is 0.6 and the probability that the ghost will be present here is 0.1. डिपेंडिंग अपॉन कि उसके नेबरिंग सेल्स के अंदर जो है वो उसके कलर के, राइट. सो दैट वुड मेक योर डिसीजन easier. Anyway, the decision that is being made presently in this video, that is not based upon probability. ठीक है. That is pure judgment. That is a decision that is not based upon some probabilistic calculations, right? Okay. um, and this is how this would work. So you can definitely make a good decision if you can assign some probabilistic values, and here is an example for that. Okay. The example for having say probabilistic values assigned to it under uncertain situation. Why uncertain situation? Because the function the sensor might malfunction. ठीक है. So you can see कि इस वक्त जो हम बात कर रहे थे, if there are two red cells, then the probability, we are not calculating any probability. That means that we are totally in a way assigning equal probabilities there. It's simply observation based decision that you have made in the last video. Lekin then you can always make some sort of probabilistic assignments to these cells. For example, in the last one, you can see that there is one cell that has got a probability of 0.81 that the ghost would be present here, and that means that this would definitely be a position जहाँ पे ghost हो सकती है. So one approach is that I've just shown you on the video. The other approach is that for every cell you calculate the probabilities and then use those probabilities to make a decision. Okay. So probabilities can be used to make decisions, and that could help you make right decisions. So we'll discuss today that how probabilities can be helpful in making those decisions, right? So under uncertain situations, there are two types of variables that you have got. One are called the observed variables. That means which you can observe, and these are what you call as evidences, right? So you can use the sensors to measure those observed variables or to find out those observed variables. The example is that symptoms are present in people suffering from certain diseases, right? So those are the observed variables. Then you have the unobserved variables. The unobserved variables are those which are those variables which can't be measured directly, right? You have to infer those variables from the data or from the observed variables. So you know the observed variables, and from those observed variables, you try to identify the unobserved variables. For example, from symptoms, you try to identify the disease, right? So disease would be an unobserved variable, whereas symptoms would be observed variables. So you can measure the temperature of body of a patient. You can find out whether the person is coughing or not. Okay. But the unobserved variables is that coughing alone won't tell you a consequences. Okay. So then what is a model? A model is primarily a relationship between observed and unobserved variables. That's what a model would be representing. So what we'll be doing in our discussion on probability is that we'll be trying to develop probabilistic models that would help determine the unobserved variables from observed variables, right? And we'll look at a framework that helps us make the decisions about unobserved variables, right? And this is what, because we are talking about probability here, so we are talking about situations where there is uncertainty. Remember decision trees हमने last discussion में किए थे. So decision trees at the one that we have discussed, ID3 based decision trees, वहाँ पे भी ऐसे ही था. I mean, the class of a variable was determined based upon, or a decision was made based upon some observed variables. For example, playing tennis or not is your output variable, and that was determined based upon uh, the weather conditions, the humidity, and the temperature, whether it's raining outside or not, stuff like that. Right? Those variables that were observable. But the difference was that in case of decision trees, the situation wasn't uncertain. All the variables were deterministic in nature. And from those deterministic variables, you were able to determine or you were able to extract your decisions. Right? Okay. I hope you are you are with me on this. Is there any question so far? Ji, Maz, Daniel, Temur, or Ali, is there any question so far on this? Okay, great. Let's just move on to the next. So let's just start with random variables. So what is a random variable? The definition is given here on the slide. A random variable is some aspect of the world about which we may have uncertainty. ठीक है? So a variable that has an uncertainty associated with it is a random variable. So will it rain or not? ठीक है? It's a random variable. Is it hot or cold outside? How long will it take to drive to your workplace? And in our example of that ghost, where is the ghost located? And these are the random variables that we have got. And these random variables may have some values associated with them. So for example, R के साथ क्या values associate हो सकती हैं? And generally speaking, I mean the nomenclature, the what you can say, the convention that we'll be following is कि random variables को हम capital letters से represent करेंगे in this. So these could have some values. So for example, R की value क्या होगी इस केस के अंदर? क्या possible values हो सकती हैं? It could be binary. It could rain or it could not. ठीक है? 0 और 1, right? इसी तरह से yes और no हो सकता है. T की भी कोई वैल्यू हो सकती है, D की भी कोई वैल्यू हो सकती है, L की भी कोई वैल्यू हो सकती है. ठीक है? L में भी where is a ghost? The ghost is present in a cell or the ghost may not be present in the cell. Right? तो उनकी कोई random assessments हो सकती हैं. So here are the values that these random variables can have. ठीक है? So the random variables may have, for example, R की value true false हो सकती है, T की value hot and cold हो सकती है, D की value जो है that could be from 0 to infinity, the distance could be very very large, the distance could be 0, and the possible location of the ghost could be the x or y coordinates that we have got. ठीक. So these are the possible values of these random variables. Okay. And with every random variable, there is a probability distribution associated with this random variable. So for example, temperature की अगर हम बात करें, there could be a probability distribution associated with temperature. How? The question is how. या किस तरह की probability distribution associated हो सकती है? जी. So you know that every random variable is associated with some value, which we have seen in the last slide. If, for example, temperature could be hot or cold, R could be true or false, L could have the location values, D would have the distance values, and what would probability distribution mean for a random variable? So we'll choose, let's say, two random variables here, temperature and weather. And Ali has rightly said that probability distribution could be the value, the probabilistic value associated with each. For example, the temperature could be hot or cold. Okay. And the probability associated with that could be 0.5. Okay. Similarly, weather. Weather, अगर चार possible conditions हो सकती हैं weather की, then those four different conditions could have different probability values based on some sort of observation. So is the weather sunny or not? The probability is 0.6. So this is what the probability distribution would be. So you have a random variable, and with every random variable, you have got some probability distribution associated with that random variable. Okay. So you need to know those probability distributions for that random variable. Okay. Then the probability distribution. So unobserved random variables also have probability distribution. So there might, so there are two types of random variables as we discussed. That you can have observed variables and unobserved variables. सो अनऑब्जर्व्ड वेरिएबल्स की भी प्रोबेबिलिटी डिस्ट्रीब्यूशंस आपके पास आ सकती हैं, और ऑब्जर्व्ड रैंडम वेरिएबल्स की भी प्रोबेबिलिटी डिस्ट्रीब्यूशंस आपके पास आ सकती हैं, ठीक है. सो a particular instance of that, for example, here, a particular instance in this probability distribution would represent a specific probability value of that particular random variable. For example, I can say that the probability of temperature being hot is 0.5, and that is a particular probability value which I have extracted from this probability distribution. And I can also have, let's say, probability of whether uh, W is foggy or not, whether W is rainy or not, or whether W is sunny or not. That single instance value can be extracted from this probability distribution. Okay, for example, probability of W equals rain is 0.1. That is given from this from from this distribution. So from the distribution, I can find out some specific probability values. Okay. And these probability values could be, and here, because these are observable variables, I can see whether it's raining outside or not. Therefore, these would be observed variables. But using this information of the observed variables, I can find out the probability of occurrence of unobserved variables also. Okay. So, so the idea here is that you have got some observed variables और उनकी probability distributions हैं, and from these you can find out the probability distribution of, or the probability values for unobserved variables or unobserved random variables. So आपके पास probability distribution of observed given है, and from there you can actually identify the probability distribution for unobserved. And that is exactly what decision making through probabilistic approach would mean. I hope you are clear on this. इसमें कोई question तो नहीं है. Now, this discussion that we'll be going through, that would pave way for making decisions based on naive based approach. अच्छा, naive based approach के बारे में you have, how many of you have heard about this naive based approach? Okay. Okay. So far you are with me. I mean, is there any confusion so far? So what are the things that we have at present? I mean, it's important that you are on the same page, because थोड़ी सी चीजें complicate होना शुरू हो जाएंगी when we'll move in further. You have variables. Those variables are random variables because they have associated some certain uncertainty with it. One thing, they have some values, and all possible values would have some probability of occurrence, and that probability of occurrence of every variable or every value that you have associated with the variable, that probability would give you a probability distribution, because there are possible values, multiple possible values associated with the variable, and we call that variable as a random variable. Therefore, you'll have a set of probabilities, and that is what you call as the distribution. Probability distribution could be for observed variables as well as the unobserved variables. The probability distribution for observed variables is known to you, and from there you will try to infer the probability of occurrence of some unobserved variables. Okay, so that's what we have covered so far. Yes, go ahead.
So in the probability distribution, is the sum always equal to 1?
Gee, what do you think?
So if we know all the possible
Yeah,
outcomes, then it can be 1.
yeah, it has to be one, right? In a probability distribution table, all the possible outcomes जो भी आपके पास आ सकती हैं, say for example temperature could be hot and cold, in दोनों को अगर आप ऐड करें it has to be 1. Similarly weather की तमाम possibilities को अगर आप ऐड करें the answer should come out to be 1. ठीक है, so the addition of all the probabilities of all the possible events should come out to be 1. ठीक है, so अगर सनी की probability ज़्यादा है तो then obviously I mean logically it should mean कि rain की probability कम हो जाएगी और बाकी probabilities जो है ना वो कम हो जाएंगी. ठीक है, सो अगर if there is indecision somehow or if there is some sort of malfunctioning जिससे आप properly observe नहीं कर पा रहे then the probabilities could be equal. I mean the probability here for example is equal but the addition of all is 1, so this is also 1, and if you add all this that should also come out to be 1. ठीक है, so you're right कि इनकी probabilities जो है ना वो 1 के बराबर आनी चाहिए. ठीक है, so probability distribution is in the form of a table that you have got, and a probability value would be one instance from that particular table. So generally one instance from that particular table is represented by small p. So मैं कहता हूँ what is the probability that it's raining? So आप उसमें से इस table में से एक value निकाल के मुझे दे देते हैं, that's the probability value. But if I say that find out a probability distribution, that would mean that you'll have to give me a probability of all possible values that W can take. That would be a distribution. That's why the word distribution is taken, because distribution has to be over certain range of values. Okay, and this is what you are referring to. The probability cannot be negative. The probability has to be either 0 or greater than 0. And the sum of all probabilities in a probability distribution should be equal to 1. Right? Okay. And uh, I mean, this is just a nomenclature thing. So the probability hot would mean that we are talking about temperature here. Probability cold would mean that we are talking about temperature here. The temperature getting the value equals to cold, and temperature getting the value equals to hot. And probability of rain would mean that W getting the value of rain. Okay, so this is just a matter of nomenclature that we have just referred here. Okay, so then you have joint distributions. The next concept is of joint distributions. And what would joint distribution mean? Joint distribution means that you are combining two or more than two random variables together. So now I'm trying to get probability distribution not just on one random variable. I'm trying to get the probability distribution on a number of random variables occurring together. For example, what is the probability or what would be the probability distribution of temperature and weather? And that would be a joint distribution. So you have a set of random variables x1 to xn, and every x would have some value associated with it. So x1 would have a range of values, x2 would have a range of values, xn would have a range of values. And a joint distribution would mean that I'm combining two together. I'm saying that what is the joint distribution of x1 and x2? What is the joint distribution of x1, x3? Joint distribution of x4, x1. Okay, so that is what you call as a joint distribution. Okay, so that would have a representation of this form. Okay, so this is a joint distribution of T and W. So the probability that the temperature is hot and weather is sunny is 0.4. So this is a joint distribution that you have got here. So this is a joint distribution that you have got. So from probability distribution of a single random variable, now you have a probability distribution over a combination of random variables, and that is what you call as a joint distribution, right? Okay. And then obviously joint distribution would always also obey certain rules, and that these are exactly the same rules जो कि मैंने पहले आपको बताया. The size of distribution if n variables with domain size t, so that means कि आपके पास n वेरिएबल्स होंगे, so that would mean that the joint distribution would have all possible combinations of the values that a random variable can take, और उनकी primarily एक टेबल का साइज वहां से डिटरमिन होगा, ठीक है। सो टेम्परेचर की दो पॉसिबल वैल्यूज हैं, और वेदर की लेट्स से यहाँ पे दो पॉसिबल वैल्यूज मैंने शो की हुई हैं, सो द टेबल वुड हैव द साइज अकॉर्डिंगली. So for every value of temperature, you'll have all possible values for W, and that would determine the size of this joint distribution table, right? Okay. So let's say, so now we have seen कि observed variables आपके पास आ गए, और unobserved variables के ऊपर भी आपके पास जो है वो joint distributions आ सकती हैं. You can have the concept of joint distribution. So once we have this in mind, then we can go over to have probabilistic model, a discussion on probabilistic models, that from this joint distribution can we determine the values of unobserved variables, कि क्या हम उनकी कोई values determine कर सकते हैं या नहीं कर सकते, ठीक है. So this is what the probabilistic models, the discussion on probabilistic models would look like. Okay, so let's just see. So random variables key, obviously you have domain of random variables. That means that there are certain possible values that are associated with random variables, and you have certain outcomes. और उन आउटकम्स को आपने कोई वैल्यू असाइन करनी है और कोई प्रोबेबिलिटी असाइन करनी है, और उसकी बेस के ऊपर आपने कोई डिसीजन जो है फॉर एग्जांपल आपने लेना है. So probabilistic models के अंदर the outcome is always in terms of the probability values. Say for example, आपके पास outcome probabilistic models में probabilities होंगी या outcomes होंगी in terms of the probabilistic models. Then you have another set of models which are called the constraint satisfaction problems. वहाँ पे the outcome is not a probability value, but the outcome is an assignment of whether whether the two things can occur together or not. For example, hot and sunny, the value could is true. That means that that's a possibility. लेकिन hot and rain may not be a possibility. इसलिए hot and rain में जो p column अगर आप देखें तो that gives you a value of f. तो अगर आपके पास outcome occurrence and not occurrence की form में हो, then that would be the constraint or CSP, constraint satisfaction problems. लेकिन अगर probabilistic models हैं आपके पास to determine the outcome of the unobserved variables, या तो उस केस में आपके पास probability values आपके पास आएंगी, ठीक है. So that has to be very clear in your mind, and we are referring to probabilistic models in this particular case, ठीक है. Whether a particular class exists or not, that would be constraint satisfaction problem, and with what probability that exists would be the result of a probabilistic model. Okay. And now let's talk about some events. So there might be certain events, certain outcomes based upon um, so for example, an event E primarily would be represented by this definition here, that it would be summed over all possible outcomes. Okay, so let's just see that how this actually works, and this can be calculated from the joint distribution table. Let's just take this example, and this would help you identify event क्या है. So you have got this joint distribution table here, ठीक है. So ये joint distribution table. So I want to find out, let's say my first question is that what is the probability that it's hot. So how can you find out that probability from this joint distribution table? So it's hot is an event, and I have to find out the value for that event from this particular joint distribution table. कैसे find out करेंगे? At both the values, right? So you have temperature hot, और उसके लिए hot के लिए दो possible values हैं. You simply add these two values and that would give you the value for this. ठीक है. Okay, the probability that it's hot or sunny, ये कैसे आएगी from this? So this is an event. और ये कैसे आएगी from this joint distribution table? Similarly, probability that it's hot and sunny. Obviously, hot and sunny का तो आंसर आपके पास straight away at this row is representing hot and sunny. So 0.4 will be the answer in the first case. ठीक है. दूसरे केस में it could be hot or sunny. ठीक है. So hot की probability आप identify कर सकते हैं. ठीक है. So hot इन दोनों probabilities को add करके hot आ जाएगा. ठीक है. और sunny किन दो values को add करके आएगा, ये value और ये value. ठीक है. सो हॉट और सनी का जो है या तो हॉट है या सनी है, तो हॉट की प्रोबेबिलिटी तो आपके पास यहाँ से आ गई और सनी की प्रोबेबिलिटी आपके पास जो है. सो लेट्स से अगर मैं ये कहता हूँ कि व्हाट इज द प्रोबेबिलिटी दैट इट्स सनी, सो यू विल टेक दिस रो और उसकी प्रोबेबिलिटी अगर आप निकालते हैं, कैसे निकालेंगे, यू विल हैव टू सम इट ओवर द टेम्परेचर वैल्यूज. सो सनी हॉट और सनी कोल्ड दोनों की प्रोबेबिलिटी निकाले और उनको ऐड कर लें, तो दिस वुड बी द एडिशन ऑफ दीज टू. राइट. आई होप यू आर विद मी ऑन दिस.
ये लास्ट वाला नहीं समझ आया.
अच्छा, लास्ट वाला देखें. अगर आपने प्रोबेबिलिटी ऑफ हॉट और सनी का मतलब दोनों में से कोई एक हो सकता है ना, राइट. सो लेट्स से प्रोबेबिलिटी ऑफ हॉट कैसे आपने निकाला था. सो प्रोबेबिलिटी ऑफ हॉट वाज यू सिंपली लुक एट द रोज जहां पे टेम्परेचर हॉट है और उनकी प्रोबेबिलिटीज को आप ऐड कर देते हैं. तो फॉर एग्जांपल दिस वन and this one. So that would give you this probability and this probability. So probability of hot would is actually summed over all possible values. So this would be for T is equal to hot. Okay. For all possible values of W. Okay. Summed over all possible values of W. Okay. So all possible values of W would be sun, sunny and rain. So इन दोनों की probabilities को आप add कर दें, तो this would give you the probability of hot. अच्छा, सिमिलरली अगर मैंने प्रोबेबिलिटी ऑफ सनी निकाला, सो प्रोबेबिलिटी ऑफ सनी वुड बी द सेम थिंग दैट दिस वुड बी फॉर W equals sunny for all possible values of temperature. So sunny यहाँ पे है और sunny यहाँ पे है. You just take these two values and you add them. So the value comes out to be 0.6. And the temperature hot के लिए value आपके पास 0.5 थी. Right. So we'll come to this point later on, and we'll see कि इसको हम use कैसे करना है. So I hope if an event is given to you, you can find out that event. So this is what we are calling as event. So if an event is given to you, you can find out the probability of that event from this joint distribution table. So joint distribution table can actually help you identify the probabilities of events. Okay. So these are partial distributions, or in a way you are saying that you have generated subtables from these joint distribution tables. Okay. I mean, here is a small exercise for you. You can actually try to do this exercise. Here the probability of plus x comma plus y, the probability of plus y, the probability of minus y or plus x. ठीक है. and this is the table that is given to you. From this table you can always find out the probability. These probabilities. Okay. So what is the first one representing? This is a probability of plus x and plus y, probability of plus x, probability of minus y or plus x. Okay. So according to this definition, अगर मैं probability of minus y निकालना चाहता हूँ तो which two probabilities I'll be adding? Minus y कि कॉलम के अंदर, y के कॉलम के अंदर ऑल रोज जिसके अंदर माइनस वाई एग्जिस्ट करता है, you just take those probabilities and add them. So this is one, this is another one. So I'll add these two, and that would primarily give me the probability of minus y, which is 0.4. ठीक है. प्लस x के लिए मैं ये वाली रो और ये वाली रो लूँगा, and I'll add these two, that would give me 0.5. ठीक है, and so on and so forth. Okay. Then you have this concept of marginal distributions, and marginal distributions would mean that जैसे मैंने पहले बात की कि आप सब टेबल्स यहाँ से जनरेट कर सकते हैं, and you can eliminate some of the variables from your table. This is what the marginal distribution would mean. You can eliminate some of the variables from here. So let's say, let's take an example, and that example is I want to eliminate, say, a variable. Let's say मैंने weather को eliminate कर दिया from this, या weather के किसी एक possible value को eliminate करना. Weather equal to sun, sunny को मैंने eliminate करना है from this joint distribution table. That means कि उसके impact को मैंने खत्म करना है. ठीक है. तो जिस वेरिएबल को मैंने खत्म करना है, I'll actually what I can do is that I can perform, I can collapse or sum out over that particular variable, और उसको marginalize कर सकता हूँ, उसको मैं eliminate कर सकता हूँ from my table by collapsing rows pertaining to that particular variable जिसको मैं eliminate करना चाहता हूँ. That means collapsing rows का मतलब ये होगा कि I'll be adding up those values. Okay. So how can I do that? Let's take an example here. कि अगर मैं इस joint probability distribution से probability distribution of t निकालना चाहता हूँ, that means I want to eliminate w from here. कैसे होगा? I'll collapse, or I'll actually be doing some sort of marginalization of w. ठीक है. इससे मैं एक सब टेबल जनरेट कर सकता हूँ, और टी की कितनी पॉसिबल वैल्यूज हैं? देयर आर टू पॉसिबल वैल्यूज, हॉट एंड कोल्ड, एंड आई जस्ट वांट द प्रोबेबिलिटी ऑफ दोस. आई हैव ऑलरेडी टोल्ड यू प्रीवियसली कि आप एक पर्टिकुलर इवेंट की प्रोबेबिलिटी आप कैसे निकाल सकते. So possible values of t जो हैं वो hot and cold हैं. I can find out the probability of hot, I can find out the probability of cold, and you already know by now कि कैसे find out करते हैं, by adding the respective columns. Hot की probability क्या होगी? Rows. Hot की probability क्या होगी? I'll add the probabilities where hot appears. ठीक है. और cold की probability क्या होगी? I can add the probability of rows जहाँ cold appear करता है. ठीक है. So if I am going to eliminate w from here, इन दोनों rows को मैं ऐड करूंगा तो probability of hot आ जाएगी, इन दोनों को मैं ऐड करूंगा तो probability of cold आ जाएगी, and this would give me the probability of temperature. So from joint distribution I have been able to marginalize w, right, by summing up all the rows for a specific value of temperature. And similarly, I can eliminate t from here. And that means that I can marginalize t from here. I can eliminate t from here. और t को अगर मैं eliminate करना चाहता हूँ, तो what would be the marginal distribution for pw? G. Marginal distribution for PW.
सर इसमें सन और रेन आ जाएगा.
सन और रेन आ जाएगा और उनकी वैल्यूज क्या आएंगी?
सन की होगी 0.4 प्लस 0.2.
विच इज 0.6 और रेन की आ जाएगी 0.4. राइट, सो यू राइट. Okay, so this is what you'll be getting. So from a complete joint distribution, we have got a subtable by marginalizing certain variables. And this is what you call as marginalization or marginal distributions. So far what we have covered is random variables की probability distribution, joint probability distribution, probability of an event, then marginalization of a variable. So this is what you call as marginalization of a variable, right? And this is the formula through which you can actually do the marginalization. Exactly the same thing. So marginal distribution आप इनकी भी निकाल सकते हैं. So marginalization of x अगर आप करेंगे p of x निकाल लेंगे. Marginalization of y अगर आप करेंगे तो p of marginalization of x अगर आप करेंगे तो वहां से p of y आएगा और marginalization of y अगर आप करेंगे तो वहां से p of x आ जाएगा, right? So what would be the values? I mean, you can easily find out कि इसमें values क्या हो जाएंगी. +1 plus x के लिए you will add these two, minus x के लिए you will add these two, and the answer comes out to be 0.5 again in both cases. और अगर मैं माइनस प्लस y करता हूँ और माइनस y करता हूँ तो this would be 0.6 and 0.4 again. So these are the probability distribution or the marginal distributions which are present here. You can calculate these values very easily without any problem. And now the last concept before we move on to the inferencing process, the actual decision making process. Now this is very important, and that is what you call as the conditional probability. So अभी तक आपने क्या किया है? So remember marginalization में आपने क्या किया था? You are eliminating the variables. ठीक है? So suppose I've got a joint distribution between A and B, which is given here, a joint distribution between A and B. And what is this representing? Anyone? What is this representing? So ये तो joint distribution आ गया ना A और B के दरमियान. And what is this?
Say total probability of set B.
Probability of B alone, that's fine. Probability of B alone, लेकिन just in the previous slide we have just seen कि probability of X alone कैसे आई थी?
Marginalize कर देंगे हम A को.
Y को.
In this case Y.
हाँ जी, इस केस में Y को. यहाँ पे आपने probability of B निकालना है. That means that from the joint distribution आप A को marginalize कर and you will get the probability of B. So that means that joint distribution table से ही आप ये दोनों values निकाल सकते हैं. ठीक है? Clear? G Mars, go ahead.
नहीं सर पहले का था sorry.
Okay, right. And if you divide the two, that means कि joint distribution of two variables divided by the marginalized value of any particular variable gives you a conditional probability. और ये conditional probability क्या है? The conditional probability. So अगर आप marginalization of A करेंगे, that means that probability of B अगर आप निकालते हैं joint distribution को आप B से divide कर देते हैं, then B becomes a condition. तो आप अपनी probability को condition कर रहे हैं over B. A की probability को condition कर रहे हैं over B. So how will you read this? This is the probability of A given B or probability of A conditioned on B. This is what you call as the conditional probability. In other words, अगर मैं इसका कोई practical example देखूं तो I can find out, for example, A represent कर रहा है some disease और B represent कर रहा है some symptom, तो I can find out the I can find out the conditional probability here, saying that the probability of a particular disease A given an evidence B or a symptom B, right? So this is what a conditional probability would look like, right? So in other words, अगर आप इसको Venn diagram की form में देखें तो the joint probability would be this whole thing. The joint probability would be this thing here. This region is the joint probability of these two variables. ठीक है, और अगर मैं उसको कंडीशन कर देता हूँ ओवर बी, सो दैट वुड गिव मी द कंडीशनल प्रोबेबिलिटी ऑफ ए गिवन बी, और अगर मैं इसको कंडीशन कर दूँ ए के ऊपर, दैट वुड गिव मी द प्रोबेबिलिटी ऑफ बी गिवन ए, राइट? बट both these things can be found from joint probability distributions. तो conditional probabilities भी मैं joint probability distribution से निकाल सकता हूँ, marginal probabilities भी निकाल सकता हूँ, और conditional probabilities भी निकाल सकता हूँ, right? I hope this is clear जी, इसमें कोई issue तो नहीं है अभी तक. Let me go over an example. Here I have got a joint distribution for T and W. यहाँ से अगर मैं प्रोबेबिलिटी डिस्ट्रीब्यूशन निकालना चाहता हूँ ऑफ टी इक्वल्स हॉट गिवन, या प्रोबेबिलिटी ऑफ टी निकालना चाहता हूँ, लेट्स से मैं वो करना चाहता हूँ गिवन वेदर इक्वल्स सनी, सो ये मैं कंडीशनल प्रोबेबिलिटी निकालना चाहता हूँ, एंड आई एम गिवन दिस जॉइंट डिस्ट्रीब्यूशन टेबल. I can easily do that. I mean, that shouldn't be a difficult task for me. I've got the joint distribution table. I know कि t की कौन सी वैल्यू मैंने देखनी है और w की कौन सी वैल्यू देखनी है, इसकी मैं जॉइंट डिस्ट्रीब्यूशन प्रोबेबिलिटी निकालूंगा, और क्योंकि द कंडीशन इज w हेयर, w इज इक्वल टू सन, तो मैं मार्जिनलाइज कर दूंगा ओवर माय condition, and that would give me the value, the joint distribution value, or sorry, the conditional probability value. Okay, so let's say कि ये तो मैंने एक एग्जांपल दिया आपको. let's say कि अगर मैं ये फाइंड आउट करना चाहता हूँ, so what do you think the value will be? The probability of W is equal to S. S is sunny, given that T is cold. Please go ahead and try to find out. So this would be, Ali said कि ये 0.2 और 0.5 है. Anyone else? 0.4. ठीक है जी, तो आप तकरीबन वही बात आ जाती है जो कि अली ने की. So this is how you can actually do this quite easily. Probability of W equal to S and T equal to C. Joint probability इनकी जो है that comes out from this row, which is 0.2, divided by the marginalized value over the condition. The marginalized value of the over the condition is T is equal to cold. तो cold के लिए marginalize अगर आप करेंगे तो weather को आप eliminate कर दें, तो whether sun and rain है, so you will just add these two values, which comes out to be 0.5. So 0.2 or 0.5 is 0.4. So that's what the marginalization would actually be. Okay, so these are the conditional probabilities that you can actually calculate. Okay, um, so these are the conditional probabilities which you can calculate from this table quite easily. I think you should be able to do that. This would give you some sort of a practice over this. It's not that difficult to understand. Okay, so conditional probabilities are probabilities over some variables fixed under some values. So आपने किसी वेरिएबल को रैंडम वेरिएबल को उठाया, उसकी वैल्यू को फिक्स किया और उसके ऊपर आपने किसी कंडीशन के ऊपर यानी किसी एक वेरिएबल के ऊपर मार्जिनलाइज करके उसको वहां से आपने कंडीशनल डिस्ट्रीब्यूशंस आइडेंटिफाई कर ली, ठीक है। तो कंडीशनल प्रोबेबिलिटीज आपने आइडेंटिफाई कर ली, तो जॉइंट प्रोबेबिलिटी डिस्ट्रीब्यूशंस आपके पास इस तरीके से दी हुई, right, which I've just shown you here, which I've just shown you here, right. So probability of W given some value of temperature. So यहाँ पे हमने specify नहीं किया कि what is the value for specific value for W. तो इसलिए एक probability नहीं आपके पास आएगी, you will have a distribution. So as you have conditional probability in the last slide just shown you, you could also have conditional distributions, ठीक है। और conditional distributions are that for a fixed value of a condition you can find out a distribution over the other random value. So for a given value of temperature equals hot, I can find out a distribution over weather, ठीक है। और यहाँ से भी आप बड़ी आसानी से इसको देख सकते हैं। सो इन द फर्स्ट रो आपने क्या किया हुआ, what is happening in the first row? First row is the probability of weather sunny given that T is hot. The second one is here the probability of weather equals rain given that the temperature is hot, and the values come out to be 0.8 and 0.2. I hope ये कैसे आई हैं, you can easily find out. जी, आप यहाँ से यहाँ कैसे पहुंचे? I hope you can work out this. Try to work out this. Remember हम conditional probabilities की बात कर रहे हैं, ठीक है। So that means कि पहले आपने जो conditional probability के लिए फॉर्मूला लगाना है for W equal to hot, और फिर आपने वही रिपीट करना है for W equal to for W equal to sun and for W equal to rain. तो दोनों को अलग अलग करके कंडीशनल प्रोबेबिलिटीज आप उनकी निकालें, पुट देम इन अ टेबल एंड दैट वुड गिव यू द कंडीशनल डिस्ट्रीब्यूशन, ठीक है। इन द फर्स्ट केस दोनों केसेस में आपने आई मीन क्योंकि कंडीशनल प्रोबेबिलिटीज आप निकाल रहे हैं तो मार्जिनलाइजेशन आपको करनी पड़ेगी, ठीक है। सो लेट्स सी ये कैसे होगा, ठीक है। सो दिस इज द मार्जिनलाइजेशन फॉर I mean the conditional distribution for W given temperature cold, ठीक है। अब वो टेम्परेचर हॉट था, आपने टेम्परेचर कोल्ड के लिए पहले वाला टेबल मार्जिनलाइज किया, दूसरे वाले टेबल में टेम्परेचर इक्वल टू हॉट को आपने मार्जिनलाइज कर दिया, यू कैन एक्चुअली फाइंड आउट दैट वैल्यू अकॉर्डिंगली, ठीक है जी। ओके, सो लेट्स जस्ट सी के किस तरीके से ये होता है। ओके, so let's just see, I mean I'll just show you the working for this पहले केस के लिए, दूसरे केस के लिए मोस्ट प्रॉब्ली, ठीक है। सो फ्रॉम हियर you can find out the probability of W equal to sunny given T is equal to C joint, this is conditional probability, and this is how you can actually do that from your conditional probability table. And remember what is happening in the denominator, you are marginalizing it, putting the values, you get a value of 0.4. And similarly you can do it for W equal to rain, given T is equal to C. Same approach, you get a value of 0.4, and that will give me a conditional distribution of W given T is equal to C. राइट सो ना सिर्फ आप कंप्लीट वेरिएबल को मार्जिनलाइज कर सकते हैं बल्कि आप फॉर अ गिवन वैल्यू ऑफ अ रैंडम वेरिएबल आप मार्जिनलाइजेशन कर सकते हैं ठीक है सो इफ यू आर डूइंग इट फॉर say for example a given value of t you will get a conditional distribution rather than a conditional probability right okay right so this is another way of doing it and I think this is not really important कि हम उसको किस तरीके से करते हैं the one which I've shown you in the last slide is good enough लेकिन here is another way of finding out the conditional distribution that means that you select the probability matching your evidence is t given c तो आप वो रोज आइडेंटिफाई कर लें और वहाँ से आप I mean अपना एक सब टेबल जनरेट कर लें दैट वुड गिव यू द प्रोबेबिलिटी यू ऑलरेडी नो बाय नाउ कि अच्छा इससे आपने इस टेबल से इस टेबल तक आपने कैसे आना है एंड देन व्हाट यू कैन डू इज कि इस टेबल को आप नॉर्मलाइज कर दें दैट मीन्स कि ब्रिंग दीज वैल्यूज in the range of 0 to 1 so if you add these two the total values come out to be 0.5 so अगर 0.5 out of total probability 0.5 0.2 इसकी है 0.3 इसकी है तो 1 में से probability क्या होगी this would become 0.4 and this would become 0.6 this is exactly the same table जो कि आपने पीछे calculate किया ठीक है so there are like two ways of doing it या तो आप इस नॉर्मलाइजेशन ट्रिक के थ्रू आप अपनी जो कंडीशनल डिस्ट्रीब्यूशन है वो निकाल सकते हैं या आपने जो कंडीशनल probabilities का जो मेथड है उसको यूज करते हुए वन शोन ऑन द लास्ट स्लाइड अब उससे आप अपनी कंडीशनल probabilities को निकाल सकते हैं राइट सेम इज द केस फॉर दिस अगर मैं यहाँ से like conditional probability of x given y is equal to minus y निकालना चाहता हूँ so what would be the final answer अगर आप normalization trick से करना चाहते हैं तो that will be relatively easier आप बहुत quickly कर सकते हैं तो आप वो रोज आइडेंटिफाई कर लें जिनमें y is equal to minus y है एक सब टेबल बना लें और फिर उसको नॉर्मलाइज कर दें so what will be the value जी just the last thing before we leave what would be the value here G okay let's just see so you can find out that I mean I haven't given that values but you can always find out those values okay anyway so this completes our discussion today so we'll meet next time with some further insights into probabilistic view of machine learning and we'll talk about Bayes rule and other rules and we'll see inferencing आप कैसे कर सकते हैं and you have already seen के partial decision making आप कैसे कर सकते हैं using these concepts of joint distributions, marginal distributions, conditional distributions, conditional probabilities and marginalization of variables ठीक है जी so that's it for today we'll meet inshallah next time